to talk about today's. Okay, my name is Go, right? So if you're eventually, right, let's say if you're joining UTAS, right, you'll be seeing me, right, teaching either partial differential equation, numerical methods, or computational finance. Then you start thinking, computational finance? Why is it got to do with mathematics here, right? We'll see, right? So this is my talk's synopsis, right? So we want to somehow, right, we have a feeling that mathematics is quite contradicting for lots of people. A lot of people feel it is very, very hard, it's very, very abstract, and then it is abstract, and then it makes people feel that where are we ever going to use it? Okay, and there are lots of other people saying that well, I know addition, subtraction, multiplication, division good enough, right? If I go into pasar, right, I don't need to do differentiation, integration. So why do I need to those kind of mathematics, right? And so on. And there are also another group of people saying that I know mathematics is important. I know mathematics is important, right? But when I say importance, right, and then I know mathematics have a lot of application. But why should I study mathematics, right? Why not I go for engineering? There are also a lot of mathematics there, right? So this is this is some of the questions that we hope that we can answer from here, okay, today. So what we want to know is that whether the maths that we really learn in our textbooks, right, is really that useful. So this is advertisement, right? This is a program promotion talk. So we try to push our degree. So I definitely I want to introduce in our LKCFES. Okay, so this is stand for Lee Kong Chian Faculty of Engineering and Science. Right, we are running 3 different mathematics undergraduates: applied mathematics with computing, financial mathematics, and also actuarial science. Okay, and we have our sister departments in Gampa who are running statistical computing with operational research and logistics and shipping, right? So these are some of the mathematics course. If you're interested, you can take a look, right? So most of the times, right, those people have doubts, right, in mathematics degrees, right, is they feel that the maths, right, in the textbooks, right, is so abstract, right? Are we ever going to use it, right? I don't know, right? So, and then another thing, right, is why do we need to learn proof, right? So why do we need to learn proof? Well, basically, it's right, we need to learn proof, right, is make sure that whatever that we are doing, right, whatever that our logical reasoning, right, is valid, right? So this is why we want to do the proof. So form 5, so you know Pembezaan, right? So you know Pembezaan, you know calculations for limit and so on. So how are we going to use it? Okay, or in particular, right, is there what is a specific usage for some specific theorems like Chinese remainder theorem, right? So this is one of the oldest theorems that we have ever, right? We use a lot of maths in our life here and there, right? Calculations of daily bills, payment to the petrol, and calculating how many tons of paint that we need in order to paint our house and so on, right? So but people will say that I don't need to do dy dx or anything to do with axiom, right, to do my shopping, right? So are you sure, right? We don't need to use dy dx in our shopping, right? So what I'm seeing here, right, is actually this just a screenshot from Shopee. Shopee didn't pay me for doing this advertisement, right? So in here, right, usually is right, we have a question. How can we get the best bargain, right? Like, should we buy the item individually one by one, okay, one by one, or should we get a bundle, right? So how do we optimize the money that we have, so that we don't spend, we don't wasted our money on the postage and so on, right? So you probably are going to compare a few of the shops, right, for different rates in the postage and so on, right? The delivery fee, right? And sometimes, right, if let's say you are going over to holidays, right? So if let's say you go to Kuching for holiday, so you want to look for the famous cat stations in Kuching, right? You want to visit the Fort Margaritas in the police museums, right, in the over the river, the other side of the river. You want to look at the old Tok Tek Kong temple here, right? You want to look at the old Sarawak Museum. So these are the places that you want to visit. At the same time, middle of when you feel hungry, right, you want to go for the famous laksas, right, around these regions, right, or you want to go to hawker centers, right, in the open air market. So how are you going to optimize your route, right, your routes, right? So this is what I'm going to say. Let's create a mathematical model and find out the optimal path. And then if you're going over with holidays, right, with your friends or whatever, right, then probably that your friends are going to look at you. Are you really serious? Why you want to make easy things like this, right, so complicated? But you think about it, right, again, is for people that are interested in mathematics, right, everything that we're interested, right, is we want to take it seriously, right? We want to take it serious. Eventually, is right, later on I'll tell you, right, is in your career life in the futures, right, a lot of skills that you learn, right, is not coming from the textbook. A lot of skills, right, is actually when you are in your education, your day-to-day life, when you practice it, okay, you set up the correct attitudes, right? Like for example, right, the qualities that maths graduates normally have, right, is they are serious or they are rigorous about their work, right, and they are actually patient. How a mathematician cannot be patient, right? Very simple, right? Is because every day, day in, day out, right, doing all those mathematical exercise, you don't no patience, right? The entire books you throw into dustbin already, right? So this example I'm telling you is right. Finding an optimal routes. We do a mathematical models. I'm telling you that our day-to-day life we need to be a serious. Okay, then you might be questioning, hey, any degrees, right, we also need that kind of quality, right? Then we go back to some things like, hey, how do I know that the mathematics that I'm using is useful? We have to start practice using it. I practice it here, right? Eventually, I can summarize, I can generalize into small rules that I can use in order for me to find out my optimal path. Then I can apply it elsewhere. For example, the supply chain or logistic industry, right? Hey, this is a multi-billion business industry. To figure out, right, the route from one country to another country, what is the optimal way of doing it? Isn't it? This is the blown up version of this little tour that we have on Kuching, maybe on one day, right? So this is the ideas, and nowadays with the more and more people stay at home because of the COVID, right? This more and more demanding, right, is actually in the routing and logistics. And many of you, some of you, right, are driving, right, and then you're using Waze, right, using Google Map and so on. All those things, right, actually also related to the pathfinding as well, right? So mathematicians, right, you say that, okay, we want to really do it seriously. Okay, now we're talking about multi-billions business, right? So in mathematics, right, these two are actually essentially they are the same. What's the difference is their scale, right? So what I'm trying to say here is, right, is because of the difference in scales, right, you will treat them differently, right? In mathematics, you see through them, they are essentially the same types of poles, okay? And but people are not willing to make any mistakes, right, in doing the multi-billion business, but they are willing to sort of like get back and forth a little bit during the tours, right? So but they do not wish to waste a single cent of money, right, for this business. So what they want, right, is that they want to have a rigorous methods, right? Otherwise, you're not going to convince your boss, right, saying that your algorithms, right, your methods, right, to of your routines, right, is the best, right? So you can see that these two particular methods. So by one guy is saying that, okay, I try to come up with all the possible scenario of all the routes that possible, right? This is of order of n to the power of order of n factorial, right? So if I use a appropriate algorithm, appropriate methods, I have n to the power of 2 and 2 to the power n complexity, right? So what's the difference? It enormously different, but we cannot see it if we don't understand mathematics, okay? And we can't even understand the jokes, right? The difference between these two, right? If we don't understand maths, like for example, this guy is joking at his colleagues, right, saying that, hey, why do you need to worry and then to visit all different places, right? So this guy, right, is trying to visit all the cities, right, to do his to send out his parcel or to do the business and so on. This guy saying, we just sell on eBay, right? So why you need you to worry about all the routing, right? So at eBay, right, is the complexities, right, is of order of 1, it's constant time. If you do not understand maths, right, you will not be able to understand the scale of the difference of these two. This one, okay, if you're doing by brute force, right, I give you the computers in the world, all the computers in the world, right, you'll not be able to solve it, okay? So when people are talking about some mathematics, right, then usually it has the impression, right, is a nerd, a nerdy guy, right, and so on. If you are talking to someone in a party or whatever, right, personally, I have a lot of this kind of experience, okay, meeting people in a airport, okay, waiting for the flights, then chit chat with the people next to you, they're asking me, what are you doing? Mathematics lecturer. Then suddenly nobody want to talk to me, right? Everything's stop die, right? Unless you'll be able to communicate well, right? So that's the impressions that mathematician given to a lot of people, right? So people are feeling it's very rigid, but things are changing nowadays, right? That we have a lots of work and careers that is actually very demanding in mathematics. And I'm saying that demanding in mathematics, right, is not saying demanding in the sense of engineering, okay? We just apply a few software, then we can solve the complicated mathematics problems. But we require the fundamental knowledge of mathematics, right? Like for example, data science. If you need to analyze the data, right, there's no specific rule for you. Every data coming in is case by case, right? You have to, if you don't have a basic fundamental backgrounds, right, it's very hard for you to make sense of the data that you want, right? So mathematics, we have people are trusting them because they always talk about the axiom, the theorems and hypothesis, right? So let's do some things lighter, right? So why do we need to prove them, right? Why do we need to learn the proof, right? So it's just not because of mathematics people, right? It's tends to be trying to be rigorous, right? We want to be rigorous. Is in the university times where we learn proof, right? Is we want to train ourselves to be rigorous. I want to train myself to be able to do logical reasoning well, and generalizations. If you can do your root finding in Kuching, you can do it for your the entire logistic company, right? And you want to be patient, right? So now Back to my synopsis, right? I'm telling you that mathematics is complicated. It's very abstract. So this is the a screenshot that I get from a textbook. The textbook, right, is talking about vector, right, or vector space. So you look at these vectors. It has some. This is so-called the axiom of a vector space. It allows you to have. If you only have vector addition and multiplication, you only need two things. This is the building blocks, right? It's just like you only have handful kind of Lego blocks. Then you can build a castle. For this one, right, is the same thing. You only have handful rules. 10 rules here in particular. Then you can generalize it and use it in many places, right? I think that some of you might not be convinced that saying that this vector space is used in many places. I will show you now, right? Let's say we start from a mouse, right? Not this mouse, okay? This mouse, right? The little mouse, right, is cute, so that's why I put it there. When you start with a mouse, right, you want to use a mouse on the computers, what you need is coordinate, right? A coordinate, right, is essentially a vector, right? A vector. You have coordinate x and y. This is our computer screen. I have a coordinate here, but this coordinates, right, is upside down, right? Upside down, right? Y-axis is this direction, x-axis is this direction. Usually in our textbook, the x-axis is this direction, the correct direction, but the y-axis is going up, not going down. Right? Is that a problem? Not really, right? But there's somehow you have to be careful with this. You need to, when you do the calculation, you need to make sure that you're going up or going down, right? So how do we generalize it? Right? We can generalize it, right, by doing redefining some other coordinate system and transforming that. Transforming coordinate system, it sounds like a very typical mathematics textbooks work. Transformation on this upside down coordinate system to the normal coordinate system that I know how to handle, right? But actually, where is the usage of this thing, right? Where is the usage of transformation, right? And some more, right, is when we are writing this particular coordinate point 1, 2, 0, and 50, right? We usually write it this way. So this is what we call the x direction. This is the y direction. Is the basis vector. It's a linear combination of basis vector. So we have two questions here. Number one, we want to transform from one coordinate system to another coordinate system. Where do we use it? We use it here. Your mouse itself, right, is on the table, but the cursor here is right on the screens, right, is actually on the screen. So it's already had one application of the linear transformation, right? We do not know, okay, we do not know the how do we use the mathematics, right? Is we do not link, okay, our daily life with the jargon that we use in the mathematics textbook, right? We use it every day, right? Mouse, computer screen, right? The cursor in the computer screen is one of these examples. Anything else? Okay, if we have a Windows that you resize it, right? This is performing some function looks like this, right? So this functions, right, it has a special name. It's called a affine transformation, right? So in this case, hey, actually this transformation I can rewrite into matrix, right? I can rewrite into matrix, right? You learn matrix in your school, right? Taking a photo, for example, is also matrix, right? So this is a pictures of a logo for Monopoly, right? So but you only have black and white, right? If you increase the intensity, you have the dot getting smaller and smaller. Is like what you get, right? Is a nice picture, right? So when you're representing an image, right, with a matrix like this, right, then there are lots of knowledge that you learn in your secondary school calculation of matrix, right, can be applied here. right? The easiest one that probably you learn in the introductory levels of matrix, right, is matrix multiplication. Matrix multiplications, right, is let's say this is my picture. I multiply with another matrix. That matrix, right, it will actually distort my picture. It maybe if it try to rotate it, it maybe try to shear it, and so on. This is a very simple, minded way of telling people what is the application of linear algebra. Right? Linear algebra, right, is a jargon in the mathematics that dealing with matrices. Right? So other than that, okay, we can have column space, we have factorization, we have singular value decomposition. Right? Let's say, oh, I start to getting headache already. So what is singular value decomposition here? Doesn't really matter. This is the algorithms, or this is the mathematics that you use whenever you create a JPEG file, right? So that when you're creating a JPEG files, right? Okay, the size of the JPEG files, right, is usually very small because of some compression, right? Is using this techniques that you learn in matrix operations. Other than that, we keep on talking about matrix. And remember that just now I told you, right, there's if I have a coordinate system, I can rewrite it into in terms of this basis x direction and y directions. This x and y, right, are vectors, right, unit vectors. Okay, if when you're learning your physics, right, in your starting from your form 4, right, first thing that probably you learn, right, is vector. So vector are quantity with magnitude and directions, right? So and then you slowly when you're progressing, right, you get to know that, hey, I can write my vector into the components, which makes life a lot easier, right? And the components, right, these guys, right, are called unit vectors. Why we stop there, right? Why we stop at the unit vectors? So for mathematics, right, we try to generalize this into something even more interesting, right? Instead of just numbers, okay, we generalize it like the vectors, right, is actually a function, right? So this technique here, right, this complicated, scary stuff, right, is called the discrete Fourier transform, right? This is also the things that when you are using your Photoshop, right, trying to sharpen your image, right, what you carry out, right, is Fourier transform here, discrete Fourier transform. It will try to, this is your original pictures, right? You try to transform it in the frequency domain. In this frequency domains, right, you filter out, okay, you apply some filter and transform it back into the normal picture domain. And you can see that the picture, I'm not sure whether you can see or not, is this one is sharpened, right? Slightly more sharpened, right? So image processing is one of them. Convolutions, right? Convolutions, like this is the original pictures. If these pictures, right, you multiply with this particular matrix, right, this is what you get, right? This is what we call the embossings, right? So this one's, right, I think, right, is sharpened again, right? This is Gaussian sharpen, okay? This one's, right, is actually detecting the outline, right? So and so on. These convolutions, right, nowadays is getting more and more useful, right? Especially is lots of you have heard about AI, machine learning, and deep learning. Most of the deep learning algorithm, especially they are using some form of convolutions. The most famous ones, right, is called the convolutional neural network, right, which is allow us to do face recognitions, allow us to detect handwriting recognitions, and so on. And having said that, right, is I'm writing it instead of a vector. I replace it with functions. I can replace it also another piecewise function. The computer font that I type here, right, is designed by a good artist. And all these good artists, right, eventually is, right, when they need to specify it into a computer, render it, right, is using it in as a spline. And the concept of how do you render this as a spline, right, is actually a generalization, right, of how do we write a point into a linear combination of a unit vectors, right? The idea is exactly the same, but I don't think that any secondary school students, right, will be able to tell you that, hey, this one is actually written in vectors, right? But it is, right? But the concept of vectors here is like is not quantity with magnitudes and directions, right? And a data set, right, is also can be considered as a vector, right? And text mining, right, is one of the most widely used machine learning algorithms, right? If you don't believe me, right, have you used Google before, right? Have you if you used Google before, right? You are one of the people that using application of text mining, right? So you key in the text and you try to match what is the website that is closest to your search phrase. This is all related to matrix and also vector space. Now, having bombard you with so many mathematics terms, right? Then let's switch a little bit of topics, right? Okay, I know maths is useful, maths is important, it's useful. How is it going to affect my career prospect, right? Eventually, it's right, I'm going to graduate, okay? So I'm not going to be a designer, right, to design a font. I don't know how to design a font. So how can I use it? Right, let's well, we are interested in mathematics, right? So we let the number do the talking, right? So this is the information that I get it from the internet, right? So in New Straits Times, right? 2 years back. So you see here is right. The idea here is right. 1.73. 173 thousands of average number of diploma and degree students entering the Malaysian workforce annually. And that is that time, yeah. And on the average, right, the high skill jobs that created in the country, right, is only 98,000. So from these two numbers, what do you see? Right? What do you see? Right? Here is saying that high skill jobs, yeah. The jobs created, right, is only close to 100,000, but we have close to 200,000 people are graduating every year. So where are the job for them, right? So this is on the same days, right? So they say the Malaysian Employer Federation's secretary saying that on the January to August, right, 2019, right, there are this amount of graduates, but job for graduates, this is graduates, I mean after you finish your degrees, there are only 50,000, but we have close to 200,000, right? So 1 in 5, right, has every one job position, right, is fight by 4 people, right? So this is numbers, and out from the this one's right is before COVID, I should say that this numbers is before COVID, and as you know, right, the effect of the COVID, right, is stronger. So the numbers, right, is even not that pretty. Okay, so the unemployed fresh graduates that we have nowadays, right, the statistics, right, social science 35, right, engineering 24. Science and mathematics and computing, right, is 11. Is one of the least, right? So this one, okay, is actually before COVID, remember? So people are asking, right? So now, is that mean employers is choosing the employee now because we only have 50,000 of job openings for graduates, but we have 200,000 jobs in the markets. 200,000 graduates in the markets. They say employer choosing the employees, right? Not really true, right? This is January 2000. It will say that 55% of companies, right, cannot find the employees, right, that having the skill that they need. So what's the issue? This is there's a mismatch, right, of the ideas of what employer want and what actually the graduates want, right? So there's different opinion. Employer will blame on the curriculum mismatch, right? Then you say that the fresh graduate is asking for unrealistic wages, right? So this is the perspective from the employer, right? This is a perspective from the employer. So employer is saying that they more prioritize, right, soft skills, right, and work experience, right? So we listen to what employer say. How about the graduates? Graduates say no. I'm not that choosy on the what kind of jobs, and I don't expect for high salary. This is not said by me, right? This is a research from Kazana Research, and then many job openings, right, are require a job experience, so that's why nobody hiring them, right? So it comes with this jokes, right? So this guy, he posted Twitters, right, saying that he saw a post the other day, right, a job posting the other day. It say the job postings that require 4 years of experience in a software called Fast API, and then this guy said he could not apply for the jobs because he's only at 1.5 years of experience, and then this guy is actually the creator of the Fast API software. So the creator of the software can't even qualify for the job posting. You can see that the mismatch of the expectations of the employers, right, and actually the job markets, right? So and different opinions. So the society expectations, right, the perceptions, right, or what should I want to tell, right, is actually the job creators nowadays, right, a lot of them, right, is actually are not matching the outputs of the graduates. There are lots of jobs advertised, like let's say this one's, right, if I'm not wrong, so I get it from the job street, if I'm not wrong, right? You have 600 over thousands of job vacancy, right? Only 50 thousands of them, right, is actually suitable for graduates. The other ones, right, you don't even need to have a degree, right? So the stories is telling you is that high skill jobs are very rare, and gig economics is on the rise. What do you mean by gig economy? Is like those people that are doing the delivery. You do not need a degree for to do that, but those kind of job is actually on demand. It's not say on demand. It's the opportunities, the vacancy is a lot there. Okay, so the reason for that, right, is because of the gig economy is, right, is because of the you have the industrial revolution 4.0. Everything's, right, is changed very rapidly, okay, and forces on the automation. The numbers of people that needed to carry out jobs is lesser, unless the running job that the robots cannot handle it, right? Even now, right, is we're talking about deliveries, right? Amazon is testing their delivery by drone already. Once it's approved, right, to run it just delivery by drones, right? You see that so many people are gonna their job gonna be wiped out, right? Because of that, right, is in the future, right, a safer, a more secure job positions, right, is those that actually with higher skill set. Higher skill sets, right, it means that you're actually analytical. Higher skill sets, right, is actually you are critical, you're analytical, you can communicate, you can analyze, okay? You have the skills of creating a new program or new procedure, right? So the higher skills, the post-COVID market that I observe is you want the skills that in demand, right, is those that cannot be automated. Right. Then I want to come back in here, right, is if you are interested with a maths, with maths, then you're interested with maths degrees, right? Whatever that I say, right, you can't be bothered, right, because you like it anyway. If you're worried about some job markets, right, for the maths graduates, right, this is something that I can tell you. I can ask you. I want to ask you one thing. can you automate a robot, right, to do proving of or to discover a new axiom, or to discover a new generalization in mathematics, right? And possibly, right, there are some softwares that allow you to help you to do the proving, right? But in order for you to do that, the robots, right, will not do it by itself. It needs somebody to input it for you, input the ingredient to it, right? So the jobs, the skill set in demand in the futures is those that cannot be automated. I cannot tell you that what are the jobs that eventually in the futures, right, will be in demand. Nobody can tell you, right? The reasons, right, is probably the jobs that we have now most in demand after a few years times, right, is not relevant anymore. Okay, the industrial revolution 4.0, right, is with using a lot of machine learning, artificial intelligence, automation, creativities. It wiped out lots of jobs. One of the examples, right, is taxi driver with the competitions of Grab car and also the others, right? So they are actually in the more disadvantaged situations. Like the example that I told you is that package delivery by drone. Once it's taking off, right? And I'm sure that there will be lesser people that you see zooming around in the road nowadays, right? With delivery, food panda deliveries of the Ninja van or Shopee, Lazada, and so on. Right? It will be by drone. So digital skills are short-lived. What you can hang on to, right, is your fundamental knowledge. So that's why I show you the statistic here, right? Science, mathematics, and computing, right, are your assets, right, of to surviving in the future, right? So mathematics graduates skill set. So you want to know what are the skill set that you have. The ability to conceive of proof, right? So this is important, right? Things are getting more and more rapid, okay? But people are more and more quantitative minded, right? If you propose a new proposal in the business arena, right? People are not like to hear that. Okay, I will propose this. Then they will ask you, what is the evidence that you're going to show me that this particular product is going to be well received by the market? You need proof, right? So when you have a concept of proof, even though you're not just proving anything, you have a concept of proof, right? You know that whatever that you do, right, you need support. It's a mental trainings that you already have. You are mathematics graduates, right? So, and then you're solving a lot of exercise. So problem solving is one of your skill. Quantitative skill set is your skill, right? Models a situation is your skill, right? So if we cannot do modelings, right, how people are going to send satellites or send a rocket to Mars, right? So they cannot test on artificial Mars in the Earth, right? So you need to do visualize the models, right? And by the way, is right, this extracts, right, is the list is still go on, and that was 2010, okay, and that one's right is actually if you are a mathematics graduates, right, in the UK, right, or in the US, right, probably you're not going to worry about your employment, or you cannot find jobs, right? You need to worry about you cannot find jobs, right? Probably it's because of the attitude issue, right? So the next buzzwords, right, in the Malaysian markets, right, is data science. Okay, so maths graduates, right, is you are naturally a data scientist, right? So this is some things that you can think of, lah, right? So not only you want to but remember when you talk about data science or you talk about job markets, right, practicality counts. You're not just taking out from the books, right? You not only you want to be able to devise a proof, but you have to also apply your reasoning as well, right? You're not just be able to use the mathematical tools, right? All the engineers can do that, right? Will you be able to do the programming yourself and visualize or and so on, right? And not just you want to use differential equations, statistical models, but you also need to know how to do the programming and computer science related machine learning, right? So I think that I don't want to bore you with the example here I have for the manufacturings, right? I think that for some of you might not be still not reaching the stage that you want to worry about joining into which industry. But I can tell you, right, is that eventually in the futures, right, data science, right, is going to be in any industry. Manufacturing is one of them, right? So data science people, right, it should be the new workers in the factory. Now the factory is, right, is full of robots and without any workers. Let's say again, more than one, right? And most of the times, right, is that they don't need the people to handle the production lines. They want people to monitor, okay, and doing modeling when the production line is going to go down. Example of my experience with some of the companies that on the manufacturing, like when they produce transistors, they want to make sure that they already mark all of them with the serial number or whatever. So they need to do taking photos and doing the image processing. Silicon wafer, they want to analyze which one of silicon wafers, right? Never have any silicon wafer they are the same. Each one of them have they're suitable for manufacturing different kind of chips. So how to optimize it, right? And when you produce integrated circuits, right? How do you optimize the routes, okay, that connecting one terminal to another terminal? Hey, welcome back. Is still again our holiday in Kuching's questions in different scale. Okay, so and machine learning as well. Okay, so the maths graduate outlooks. I don't want to bore you with all the words here. I just reiterate 2 items. The skills most in demand, those cannot be automated. And please learn and unlearn something every day, right? So anything that you learn today is, right, it might be go obsolete tomorrow, right? So learning is a never stop journey. Thank you.